So in this video, we're going to study the science on how to evaluate arguments and reasoning. Let's start learning objectives. So at the end of the discussion, the students are expected to letter A, illustrate a proposition, letter B, distinguish between simple and compound propositions, letter C, perform the different types of operations on propositions. Letter D, determine the truth values of propositions. Letter E, illustrate the different forms of conditional propositions. And last, illustrate different types of tautologies and fallacies. Okay. Now let's have first an activity. So let's identify the type of sentence being illustrated by the following. So basic English. So when we say type of sentence, that is the imperative, interrogative, imperative, and the exclamatory. So we need to identify what type of sentence is being illustrated. Number one, the final examination of the senior high school students in Ateneo Dinaga is scheduled on December 16 to 18 of 2020. So this is an example of declarative sentence because it convey information or make statements. Number two, how can you pass the final examination? So this is an example of interrogative sentence because it requests information or asks questions. Number three, I can ace the exam. So there is, it shows emphasis. So this is an exclamatory sentence. Please help me study for the final examination. So there's some commands or requests. So this is an example of imperative sentence. Last, our general mathematics teacher is a female. So this is an example of declarative sentence. All right. So why do we need to study the type of sentences? Because one important terminologies that we have in logic is what we call proposition. So what is a proposition? A proposition is a declarative sentence that is either true or false, but not both. So again, proposition is a declarative sentence. If true, then its truth values is if true, then its truth value is true, denoted by capital letter T. If false, then its truth values is false, denoted by capital letter F. And proposition is usually denoted by small letters. Determine whether each of the following statements is a proposition or not. Since we already defined what is a proposition, now let's go back to our first example. That's our first activity. Let's determine again if whether each of the following statements is a proposition or not. Number one, the final examination of the senior high school students in Ateneo Dinaga University is scheduled on December 16 to 18 of 2020. First, this is again, as we answered this a while ago, this is an example of declarative sentence, and this is stating a true statement. So this is an example of a proposition. Again, it satisfies the definition that we do have for proposition. Number two, how can you pass the final examination? So this is an interrogative sentence, so this is not a proposition. I can ace the exam. So this is not a proposition since this is an example of, this is an exclamatory sentence and it's not declarative. Please help me study for the final examination. So again, this is an imperative and we cannot determine whether it's true or false. Number five, our general mathematics teacher is a female. So this is an example of a declarative sentence and it can be either true or false depending on it depends on the situation. So again, number 5 is an example of proposition. All right, since we already have the idea of what is a proposition, let's proceed with simple and compound proposition. A simple proposition is a proposition which cannot be broken down any further into other component propositions. Example, pi is an irrational number. So it cannot be broken down into other component propositions. So this is simple proposition. Compound proposition is a proposition formed from simpler propositions using logical connectors or some combination of logical connectors. Some logical connectors involving propositions P and or Q may be expressed as follows. So not P. So again, the logical connectors that we do have, not P, P and Q, P or Q, if P then Q. Example of a compound proposition, either mathematics is fun and challenging or it is boring. So as you can see, it is composed of 2 or more simple propositions and with the use of logical connectors. So this is an example of compound proposition. So again, the difference, simple cannot be broken down any further into components of proposition, while compound proposition naman is a combination. It's proposition formed from simpler propositions using logical connectors. All right, next, determine whether each of the following statements is a proposition or not. If it's a proposition, identify whether it's simple or compound proposition. For letter A, we do have here God bless, which is an exclamatory sentence, and it doesn't satisfy the definition for proposition. So this is not a proposition. Letter B, Jose Rizal is our national hero. This is a declarative sentence, and it's a true statement. So this is a proposition, and this is also a simple proposition. Since again, it cannot be broken down any further component propositions. Who is the third president of the Philippines? Interrogative sentence. So automatically, this is not a proposition. Next, 3/4 is an integer or a rational number. So for letter D, this is an example of a proposition. So what type of proposition? So it's an example of compound proposition because of the logical connectors or. So it can be broken down into 2 simple propositions. Smile at your classmate. This is an imperative sentence. Therefore, this is not a proposition. Next, 2 is even and prime. So this is an example of a compound proposition. So therefore, this is a proposition since first, it satisfies the definition that we do have for proposition, and it can be broken down into 2 simple proposition. 2 is even, 2 is prime, and with the use of the logical connectors, which is and. So if an integer is even, then its square is also even. So with the use of, so this is an example of compound proposition as well. So this is also a proposition. Okay. Next, logical operators. Truth table. So we do have the truth table. So truth table, given a proposition, its truth table shows all its possible truth values. So meaning to say, the truth table tells us possible outcomes of statements and connectives. In general, a truth table involving n proposition has 2 raised to n rows. For example, suppose P, Q, and R are propositions. So we do have three propositions in all. Then truth table involving the given proposition has 2 raised to 3 that is equal to 8. So this is an example of the truth table having 3 propositions. As you can see, three propositions, 8 rows. Next, negation. The negation of a proposition P is denoted by, so this is, please take note of this symbol. So this is the notation that that is being used for negation. And it's read as not P. And it's defined through its truth values as follows. So for example, tomorrow is Wednesday. So what is the negation? Tomorrow is not Wednesday. Or angels exist. So what is the negation? Angels does not exist. So that's an example of negation. So and it's defined through its truth value. If the proposition is true, then its negation is false. If the proposition is false, then its negation is true. So I hope that it's clear. Please take note of this. Conjunction. Okay. So the conjunction of propositions P and Q is denoted by this symbol. So this is the symbol, okay, that we do have for conjunction. Okay. And it's read as P and Q. And it is defined through its truth table. So P and Q here, we call them conjuncts. So the conjunction P and Q is true, okay, only when both conjuncts P and Q are true. Okay, so ang ibig sabihin, to summarize this table, okay, the conjunction P and Q, okay, is true only when both conjuncts P and Q are true. So the rest, false na sila. Okay? If the conjuncts P and Q are true, then P and Q is also true. Please take note of this truth table for conjunction. Okay? Because again, this will be our basis in evaluating arguments and reasonings. Evaluating an arguments and reasoning. Disjunction. The disjunction of propositions P and Q is denoted by this symbol. Please take note, okay? This is the symbol that we do have for disjunction. And it is read as P or Q. And it's defined through its truth value, truth table. Okay, so this is the truth table for P or Q. So we call P and Q as disjuncts. Okay? We call them as disjuncts. So ano ba ang summary nito? Isa-summary natin tong table na to. The truth table tell us that disjunction P or Q is false when both disjuncts P and Q are also false. So the rest is true na siya. Okay? So unlike doon sa conjunction, that the conjunction P and Q is true only when both conjuncts P and Q are true. And the rest is false na. Dito naman sa disjunction, okay, magkakaroon lang tayo ng false if P and Q are false. Please take note of that. Conditional. conditional or propositions P and Q is denoted by this symbol. So P arrow Q. And it's read as if P, then Q. Okay, so better than P implies Q. So we can also write that as P implies Q. And it's defined through its truth table. Okay, so the proposition P, we call it as hypothesis, and Q, we call it conclusion. Okay, the conclusion. Now, if the hypothesis is true, and if the conclusion is true, P implies Q that the result is true. If the hypothesis is true, the conclusion is false, then P implies Q, okay, is false. If our hypothesis is false and our conclusion is true, then our P implies Q is true. If our hypothesis is false and our conclusion is false, then P implies Q is true. And that is for conditional. Biconditional. Okay, the biconditional of propositions P and Q is denoted by double arrow, and it's read as P if and only if Q. So the shortcut for that, you may also try this. It's also possible. So P if and then letter F. That is also valid. All right, next. And it's defined through its truth table. So this is how we define biconditional. Biconditional. So to summarize naman the biconditional, the truth table of a biconditional tell us that its truth value, okay, its truth value is true. Okay, truth value is true. This one. I'm referring to this. If its truth value is true when the truth values of P and Q are the same. So we call P and Q as components of biconditional. So if it's both true, okay, then the answer is true. If it's both false, the answer is also true. So that's how you summarize biconditional. So the truth table of a biconditional tell us that its truth value, again, tell us that its truth value is true when the truth values of P and Q are the same. Okay? The same. So if it's not the same, then the truth value is false. That's for biconditional. All right. Next, express the following propositions in symbols, where P, Q, R, and S are defined as follows. So we do have first proposition, Neil is a big eater. Second proposition, Len has a big voice. Third proposition, Jarek likes to travel. Fourth proposition, Lemmy likes violet. And it's represented by small letter P, Q, R, and S. Now, our task is to express the following propositions in symbols. Okay? So these propositions, we need to express this in symbol. So we already discussed the negation, the conjunction, the disjunction, the biconditional, and the conditional. So we just need to express the following propositions in symbols. So for number one, while Len has a big voice, Neil is not a big eater. That's for number one. So dito na lang ako sasagot. While Len has a big voice, Neil is not a big eater. So Len has a big voice, so the symbol for that is Q. Okay, now additional information. If you see a comma here, okay, combining two propositions, okay, so this is for conjunction, okay. Also this symbol, okay, this one. So this is also for conjunction. So Q, conjunction. So this is the symbol that we do for conjunction. Neil is not a big eater. So we only have here Neil is a big eater. So this is a negation of this proposition. So what is the symbol? So the negation, this is the symbol, and the proposition, the symbol for that proposition. So that is the answer for number 1. Next, number 2. Jarek likes to travel or he does not. Okay. Jarek likes to travel or he does not. Okay, I'll be giving you time to also think about it. So for Jarek likes to travel, so it's the symbol for that is R, or this is this junction. So the symbol for this junction is this one. He does not. So it's the negation that Jarek likes to travel. So it is represented by not R. Okay, not R. All right. Number 3. It's not true that Neil is a big eater and Lemmy does not like Violet. Okay, so it's more on the negation is distributive to Neil is a big eater and Lemmy does not like Violet. So we have here the negation that Neil is a big eater. So that is P. And we have here conjunction and Lemmy does not like Violet. So that is negation or not S. Okay. All right. So that is the answer for number 3. Number 4. Neil is a big eater or Len has a big voice if and only if Lemmy likes Violet and Jarek likes to travel. So this is a biconditional. Okay. Example of biconditional. So we have our first group. Neil is a big eater or Len has a big voice. So parentheses. So we have here. Okay. Para hindi kayo malito dito. Okay. Hindi natin din parentheses. Now sa big eater. So that is P. Or, so that is this one. This is the symbol. Len has a big voice. Len has a big voice. That is Q. If and only if. So that is double arrow. This is double arrow here. Lemmy likes Violet. Likes Violet. So that is S. And Jarek likes to travel. So that is conjunction. Jerry likes to travel. So that is R. All right. So as easy as that. So that's how you, again, express the following propositions. This word into symbol. All right. Next. So let's have the other way around. So express the following proposition in words where P, Q, R, and S are defined as follows. So the same given. So I just need to write this proposition symbol in words. Okay, so this is number one. So P, so that's P, so that's Neil is a big eater. And then this is a conjunction, so we use and this is not Q. So this is Len has a big voice, so the negation of that is Neil is a big eater and Len does not have a big voice. So that's how you write this symbol into words. All right, next. Oops. So as you can see, this is something that is distributive. Okay, like our example a while ago. So this is in not open close parenthesis Q or R. Okay, so how do we write that in words? So it is true that Neil is a big eater, or Jerick likes to travel. So Q, that is Jerick likes to travel, and Q, Len has a big, I'm sorry, parang may mali yata. Q is, Len has a big voice, dapat, sorry. So may mali tayo dito. Okay. It's true, ang Q natin supposedly ay dapat Len has a big voice. It's not true that Len has a big voice. Has a big voice. Okay. Nalito na ako. Okay? Big voice dapat siya kasi Q yung symbol na ginamit natin. Okay? Or Jerick likes to travel. Okay? It's not true that Len has a big voice or Jerick likes to travel. Next. So this is how you write the symbol in words. So P, Neil is a big eater, and so the negation of Q, Len has a big voice, Len does not have a big voice. And then this is the first group. Then the disjunction or Jerick likes to travel, that's for R, and the conjunction symbol, so we use and. Then S, that's Lemmy likes violet. Okay, very, that's correct. Now, next. So the difference just we use here implies the arrow, meaning to say it's conditional. So we use the word if then for this example. So if Neil is a big eater, okay, so that's P. And then we do have the conjunction and a conjunction symbol here, so we use and. And then not Q, so that's not Q. Len does not have a big voice, so that's the negation of that. Then, okay, since it is conditional, okay, so we use then, if then. Another group R, so R here is Jerick likes to travel, and then the conjunction and because of the symbol. Lemmy, and then S is Lemmy likes violet. So again, that's how you write the symbols into words. Okay. Find the truth values of the propositions below, considering that P, R, and S are true and Q is false. So please take note. P, R, and S are true and Q is false. Okay? Then we need to find the truth value. So for number one, so this is how you summarize the truth table for this proposition. So you just need to write all the components. So for P, the truth value for P is true, diba? According to our given, P, R, and S are true, and Q is false. So Q is false and not Q. So the negation of this one is true. Okay. You can check that on our given table for negation. That the negation for if it's false is true. Now we just need to know, okay, this is conjunctions. So the conjuncts of P and not Q. So what is the result? So anong sinasabi nga ng conjunctions? Ng conjunction? The conjunction P and Q is true only when both conjuncts P and Q are true. Again, the conjunction P and Q is true only when both conjuncts P and Q are true. So since this is both true, it conjuncts the symbol P and not Q is both true. Okay, then this is true. You can check that on the truth table for conjunction. Next, again, you just need to rate all the components. So for Q, so we know for a fact that this is false. For R, that is true. So that is true. Since this is distributive, so not Q, not R, so the other way around. So the negation that is true, the negation of true that is false. Now, the negation, the disjunction of not Q and not R is, so anong sinasabi naman ng disjunction? The truth table tell us that the disjunction P or Q is false when both disjuncts P and Q are false. So, since it is true and false, then the result is true. Okay? So, I hope na maliwanag tayo, mga kapatid. Okay? So, again, it's true and false, then the answer is true. Next. Again, just need to write all the components. So, we do have here the truth value for P is true. The truth value for Q is false. For R is true. For S is true. Not Q. So that will be the negation of this statement. So magiging na siyang false. Now, P and not Q. So conjunction. Again, we just need to review the truth table that we do for conjunction. So if it's true and false, what is the result? That is, it should be, sorry for that. Sorry. May mali tayo dito. Eraser. Okay. Oops. Okay. It should be true. Okay. And since it is the proposition, the disjuncts P and not Q is both true, then it is also true. And R and S, the disjuncts of conjuncts of R and S is also true. So the disjuncts of this is truth value for this and this is, since it is true, this is true, the disjuncts of that is, the truth value for that is true. Okay. Since it's true and this is true, then it is true. All right, next. So it's the same. Okay, it's the same. Nagkaiba lang po sa dito. No. The same. Nagkaiba lang sa this is disjunction. This is conditional. So true, false, true, true, true. Okay, this is also true. This is also true. So the see if our hypothesis is true and our conclusion is also true, it implies that the truth value for that is also true. You can check that on your given truth table for conditional. Now we also have here biconditional. So we only have here P and not P. So P, that is true. So the negation of that, not P, is false. So the components, okay, the components P and not P, okay. So since this is T and this is F, so what is the result? So anong sinasabi ng biconditional? Okay, doon sa ating truth table. So it tells us that its truth value is true when the truth values of P and Q are the same. Since this is not the same, okay, since this is not the same, the result is false. All right. So that's how you find the truth values for the propositions. So thank you for listening, and I hope that you learned. Goodbye.